Right. Good evening, everyone. In the last videos, we have seen very clearly up to we discussed very clearly about tree data structure. Okay. So, what is mean by tree data structure? How we are going to represent that tree? Okay, and what are the terms which are available in the tree? Like root means what, node means what, edges means what, path means what, leaf nodes, height of the tree, level of the tree, parent, so child, siblings means what, degree of the tree, degree of a node, degree of the tree, ancestor, predecessor, successor, and even we started binary tree. So what is mean by binary tree? How we are going to represent this binary tree? Okay, so how to represent these binary trees? So even we covered this binary tree representation by using sequential, that is by using list concept. Suppose if you have linked list representation also we covered, and even we have seen binary tree traversals. So in three orders we can visit the binary tree. Okay, first one is nothing but in order, where first priority will be given to left nodes, left subtree. Next level priority is given to root. Next level priority is given to right subtree. And coming to pre-order traversals, here the first priority will be given to root, next priority will be given to left, next priority will be given to right. In the post order, the first priority will be given to left, next priority will be given to right, and last priority will be given to root. Like that we have. So yesterday we implemented the creation of a binary tree by using list, and even we have seen the creation of a binary tree by using linked list. Of course, by using linked list, if I want to create a binary tree, then it is a difficult task. We need to analyze and we have to provide the code in the main method. So which is never recommended. Of course, in the binary search tree, we have an option to perform insert operation. Directly we can insert the nodes. But in the binary tree, we can't do such type of operations. The reason for that is nothing but binary tree is not going to have any proper structure. That is the reason why we are not going to insert directly. Next. So these are the things which we covered in the last video. In today's session, we are going to talk about in order, how to print in order, and even how to print in pre-order. Even we are going to see how to print the data in post order. All these things I am going to explain in a single program, sir. Let us take Python program, sir. I don't want to take this linked list, so I will take this list representation of this binary tree. Right. So just let me revise for 1 or 2 minutes. I have a tree is there where it contains a node. I have a constructor. There I am going to define data field, left subtree, right subtree. And in the init method, I am initializing the root of the tree is nothing but none. And whenever we are calling create tree function, then it is going to take these values. So next and after that, we are going to call utility function with the given list of values, and I am going to pass what is the starting index value 0. So first we are going to create a node with the starting value. Then we are going to identify the left index. Then we are going to identify the right index. If left index value is less than the size of the list, then happily we can able to put that particular node into the left subtree. And if right index value is less than size, and we are going to insert that element in the right side, and we will return that current node. And this process will be repeated for all the nodes. And even we have seen how to print the values in order. Okay, so like if you take this diagram, so which one will become root node here? Sir, one is nothing but root node. Okay, Left subtree for this is nothing but 2. Right subtree for this is nothing but 3. Left subtree is nothing but 4. Right subtree is 5. And its left subtree is 6 and its right subtree is 7. This is the tree, right? For that already we know what is in order. In order is nothing but what? First we have to visit left subtree. In the left subtree is nothing but one left subtree is 2. Unfortunately, it is also a tree, right? That's why we have to apply the same principle for this, where the first element, leftmost element is 4, root should come in the middle, then right element. So left subtree visiting got completed, then root node we have to visit, then right subtree. In the right subtree again we have to apply the same principle, where I am taking left subtree and then root node and then right subtree. Like this I am taking. This is nothing but in order what we have. Sir, I want to take a pre-order. Pre-order means what? First we have to visit the root node. Here root node is 1. What is its left subtree? 2. But again it is a tree, right? That's why its left node is nothing but 4. And next we have to visit, sorry, we have to visit root first 2. Then left subtree is 4, right subtree is 5. So this part completed. Coming to the right subtree, again we have to visit root first, then left subtree, then right subtree. If you take post order, so what is mean by post order? We have to visit the node at the last. I mean, root node is going to be visited at last. Sir, if you take 1, what is its left child, sir? 2, 4, like this we have, right? First we have to visit left. So in the left, again we have a subtree. We are going to visit 4 first, then right subtree 5, at last root. Sir, for this one, left subtree visiting got completed. Don't print root directly. Try to visit right subtree. What is the right subtree that we have? So we have to visit again left subtree, right subtree, and then root node. And the main root node will come here. This is nothing but what is in order, what is pre-order, and what is the post order of this tree. I think yesterday we have seen already in order. Now we have to implement a pre-order and post-order. Sir, please confirm, is the concept wise? Do you have any doubts, friends?
No, sir.
Please confirm everyone. Is the concept is clear? So in order output is nothing but 4251637 we are expecting. Sir, same I will call for pre-order. Same thing I will call for post-order. If you call pre-order, the output what we are getting is 124, okay, and then 5367. Post-order 4526731. Like this we are going to get. Okay, let us see how we are. Dinesh, please be on mute.
Yes, sir.
Now, let us see how we can do. Sir, is it same like this particular order? But the only thing is nothing but we have to change the method calls. So in the case of in order, we created the main function and we created utility function. Same for pre-order also. First we are going to create the main function, then we are going to call utility function. So here also in the utility function, in the pre-order, the first priority is given to root node. Next remaining things will come. That's why here I am going to print the data and then I will apply the same process for pre-order for the left subtree and then right subtree, because in the pre-order first priority will be given to root node. Next we have to apply this process recursively for left subtree and we have to apply for right subtree. Sir, same like post order also. In the post order what we are going to do? In the post order what we are going to do? We have to create a utility function where we will pass first we will visit left subtree and then we will visit right subtree. After completion of that we are going to print the root node. So except that there is no change, right? Let me check whether we are getting same output for these inputs or not. Okay, we will run the code and we will check whether we are getting the same output or not. So py space I am taking test.py. As you can see, the in order is 44251,637 and 1245, okay, 367 and 4526731. Like we are getting in order, pre-order, post-order. I think you people understood very clearly how we can able to work with this in order, pre-order and post-order. Can you please confirm, is the implementation wise? Do you have any doubts? All these recursive functions we have called. Any doubts, friends?
No, sir.
No, sir, clear.
Right. Next. Sir, very, very important thing. The next concept for the same, sir, I want to apply level order traversal. Sir, what is mean by level order traversal? Very simple. Level order in the sense. So do you know in the first level, what elements are there? 0th level 1. In the next level we have 2 3 is there. In the next level we have 4 5 6 7. Like this level wise I want to print. This is the first level, next level, like this I want to print. Sir, how to do that? It is a somewhat tricky, sir, but we will implement that. So I am removing all these things. I will try to print in order and I will implement the function called level order. So the output which I am expecting for this is nothing but I need to get a 1 and then 2 3 and then 4 5 6 7. Like this I am expecting. Sir, how we can able to do that? We have to implement a function. So now it is not recursive function. Integer, I am taking print underscore level underscore order. We are going to take only self. Sir, to visit these nodes in the level order, first I am going to check array boss is self dot root is equal to none. Means what? If there is no element, simply I am going to return none. If the elements are not there, how you can traverse? Simply I am going to return none. Otherwise, I will maintain a queue. I will maintain a queue. In that queue, I am trying to append so your root node first. Then in that queue, I am going to append so none value. These two values I am appending into the queue because sir, why queue concept is required? Listen carefully. I will create a queue. I will put the first node. Then so first level got completed, right? It will print this one. In the next level, what I am doing is I will identify the left node for this one and right node for this one. I will try to append those two elements and we will remove the element called 2. 2 will be printed. I will remove 3. 3 will be printed. What are the subtrees for 2? 4 and 5. Those two things will be added. What are the subtrees for 3? So 6 and 7. Those two will be added. So next popped element is 4, that will be printed. Is there any left and right child for 4? No. Is there any left and right child for 5? No. Is there any left and right child for 6? No. Is there any left and right child for 7? No. Like that we are going to get. But don't worry, with the help of example, I will explain these things very clearly. Let us see here. Sir, first, which value we are going to take? I have taken a queue. In that queue, sir, I inserted root node. What is the root node that we have? 1. 1. So next element which I inserted is none. Why we have taken none? In the sense, in the level order, after printing the first level, I need to transfer the control to next node. We know in the root we have only one element. That's why I inserted that and immediately I pushed none. None indicates that there is a new line character. Beyond that, nothing. Right. Sir, my queue is ready. Now I am going to check array boss. Is the length of the queue is not equal to 0 or not? Yes. Here my queue length is 2. We don't have any 0 elements. Then temp is equal to try to pop the 0th elements. In the queue, which technique it is going to follow? First in, first out. So which item we inserted first? One. That node will be removed and it is there in the temp. Now we are going to check. Is temp is equal to none? If temp is equal to none, some other task we will perform. If temp is not none, then I am trying to print temp dot data, and I am giving end is equal to space. Sir, I printed temp dot data. Okay, and end is equal to I have given empty space. Okay, then now can you please cross check? Is the left element is not equal to none? Sir, now temp dot data 1, we removed this 1 from the queue. 1 is removed from the queue and it is not equal to none. It will print that 1 as the output. I got 1. Then we are checking. So is that node 1 is left child is not equal to none? Yes, for one left child is available. So what we have to do, sir? If it is there, then q dot try to append. So temp dot left node. Sir, which node will be appended now? What is the left to this one, sir? 2, right? 2 will be appended into the queue. Okay, 2 will be appended into the queue. Now, can you please cross check is right node is available or not? How to do that? Temp dot right is not equal to none means try to append that right node also into the queue. What is a right node here? We have 3. So 3 also I inserted into the queue. Yes, both appended, sir. Now we are going to check. Sir, is while length is not equal to 0, we have 3 elements are there. Now can you please pop the next item? Already one item removed, next item will become none. If temp is equal to none, what we are doing? Sir, whenever you are getting temp is equal to none, the meaning is that that level got completed. So now I am going to print empty line so that the control will come to the next line. This is the reason why I am taking temp, sir. After this, I will check is the length of the queue is equal to 0. If length of the queue is equal to 0, break. Otherwise, in the queue, try to append one more none. Now cross check. So is the length of the queue is 0? No. Try to append none, sir. Now please listen carefully. Next time onwards, how it is going to work. So if a cart completed, else part won't execute. Now what will happen? Again, it will check. Is the length of the queue is not equal to 0? Yes, it is not equal to 0. Can you please pop the 0th element? Now 2 is deleted. Is 2 is equal to none? No. Then print that data. 2 will be printed on the output. Please listen carefully. Then is 2 left node is not none? Yes, it is not none. Try to append that node into the queue. Then check 2 right node is not equal to none. Yes, try to append that into the queue. Okay, completed, right? Again, we are checking is q is not equal to 0. Yes, not equal to 0. Try to pop the next item, which will become 3. Is 3 is equal to none? No. Then print that 3. 3 got printed. Please listen. Is 3 left node is not equal to none? Yes, try to push that into the queue. Is 3 right node is not equal to none? Yes, push it into the queue. Next, we are checking. Since while loop, temp, pop of 0, which is become none. Is a temp is equal to none? Yes. Now print ln. The control will go to the next line because next level got printed. Then we are checking. Is length of the queue is 0? No, sir. Then try to append none, which indicates after 7, there is no more nodes in the level. Then, so else part is going to be executed. This if condition just now we finished. Next item which is going to pop is 4. Is temp is equal to none? No. Then print the data called 4. Okay. And try to identify is there any left. For 4, what is the left node? None. So if condition fail, this second if condition is also failed. Again while loop is q is not equal to 0. Yes. Pop the item called 5. Is 5 is equal to none? No. Then print the value 5. For 5, try to identify the left node and right node. Both are not existed. Again go to the condition. Is q is not equal to 0? Yes. Try to pop the next item, which is nothing but a 6. So is it equal to none? No. So print the value called 6. Okay, and check left subtree and right subtree of 6, which is not there. Then pop the next item, which is nothing but a 7. So is temp is equal to 7. So is it none? No. Then print the data. 7 will be printed. Now temp is its left node is not there, right node is not there. Again go to while loop. Try to pop the next item none, which is equal to none. Print the new line. So the control will come to the next line. Now we are checking, sir, is the length of the queue is 0 or not? Yes, we have deleted all the elements. My length is queue is 0. Then break. Break means it will come out from the while loop. Sir, is it our expected output or not? Yes. Can you please confirm, is the theoretical concept how we are printing, is it clear for everyone, sir? Level wise, how we are printing, is it clear?
Yes, sir.
Please
No,
confirm, friends.
no, sir. Can you please explain from the starting? Actually, not able to understand like what why you have used after temp is equal to none. You are using length and then you are moving out from the loop.
Hmm.
That thing.
Concept itself you have not understood. Huh?
Yeah, yeah. While
Sir,
loop after while loop. If you
yeah,
can.
very simple, sir. I will give briefly. Please listen.
Yes.
Very simple, sir. I am taking a queue here. Okay. The
Yes.
first element which I am getting is nothing but root node and one empty. Root node is 1. In the queue, I will put 1. Okay.
Okay.
This is the first line.
Yeah.
Then this is the first level. In the first level, only one node is there, right?
Yes.
That's why to get control to the next line, I am going to insert one special attribute called none, empty object. Only
Yeah.
for getting the control to the next line.
Yeah.
This is the main first thing. That is, one is retrieved and it is stored in the queue. Now it is not yet printed. Now I am writing a while loop. This while loop is going to do two activities. First activity is it will check is the new line, that is level got completed or not. If level got completed, we are printing an empty line and we are checking is the length of the queue is 0. Suppose while printing the level wise, if all levels got completed, your queue will become empty. Then we are going to break the process.
Yeah.
Otherwise, once if the level completed, then what is the meaning? If next level is there, after printing that also we have to give none rights,
Yes.
new line character. That's why if length is not equal to 0, then we are appending the none.
Yeah.
Okay. Now, what is the first process? We are retrieving one item, q dot pop. First element which is inserted is 1 that we are removing from the queue.
Yeah.
Is it none? No rights.
No.
Then else part, we are printing that in the first row.
Yeah.
Then we are identifying, is there any left child for 1? Yes, left child is there. Try to append that left child into the queue. And
Yeah.
check, is there any right child? Yes, right child is also there. Try to append it to the queue.
Yeah.
So with this one level got completed, right?
Yes.
So now 2 is also inserted into the queue. 3 is also inserted into the queue. Again, while loop. Is length of the queue is not equal to 0? Yes.
Yes.
So temp is equal to q dot pop. Which item now it is going to
So
remove? None.
yes.
So now what will happen? If temp is equal to none, then one level got completed.
Okay.
We are printing the control. Like empty print line, it will control will come to the next line. Now we are checking, is length of the queue is 0? No, because we have still two more elements are there. That's why what I am doing, q dot append. That means none will be inserted because we fetched left nodes and right nodes. That means the task is completed in the next level. That's why I am inserting none. That means to come to the new line.
Yeah.
Then what will happen? So it is appending none and else part won't execute. The control will continue from again. Is q is not equal to 0? Yes.
Yes.
Try to pop the item. Which item is going to pop?
So
Next level, that is 2. So is temp is equal to none? No.
no.
Now print the data. Identify the left nodes and right nodes of 2. 4 and 5. Those two will be appended into the queue. Okay.
Yeah.
So next again while loop. Next node
Three.
which we are going to get is 3.
Three.
3 is not none. And try to print the value 3 in the same line. Next line is not there. Then try to identify the left node. Yes, for 3 left node is there 6. For right node is there called 7. Those two we are putting into the queue. Then again pop the next item, none. If it is equal to none, that level got completed. So we are checking, is the length of the queue is 0? No.
Yeah.
Then q dot append of none. This level got completed, so we are appending none.
Yes.
Now next element not equal to none, print the data. its left child and right child are not there. Then pop next item which is not none, left child and not right child are not there. So pop the next item, left child and right child are not there. Pop the next item, left child and right child are not there. Pop the next item, none. So print the new line character, the control will come to the next. And is the length of the queue is 0? Yes. Now it will terminate.
Okay. Now it's clear, sir.
Right.
Yeah, clear.
Everyone please confirm, is it clear?
Yes, sir. Okay.
So now we have to test whether it is working properly or not. Let us try to insert 8, 9, so 10, 11, 12, 13, 14, 15. Now total how many nodes will be there, sir? We have almost another level also will be there, like 8, 9, left and right child for 4. Okay. So 10 and 11, left and right child for 5. So 12, 13, left and right child for 6. 14, 15, left and right child for 15. If you want, you can understand like this. For 1, 2 and 3 are nothing but left and right child. And for 2, 4 and 5 are nothing but left and right childs. Okay. And for 4, 8 and okay, for 4, so 8 and 9 are nothing but left and right child. For 5, okay, so 10 and 11 are nothing but left and right child. For 6, 12 and 13, like this we are going to get. I can say this is nothing but just for your understanding purpose. Now let me execute this code, sir. Is it coming in the level order or not? You can see 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15. Like this we are getting. This is nothing but level order traversals what we have. Is the execution, is it clear for everyone?
Yes, sir, clear.
Right. Coming to the next one, sir, we are going to talk about counting the nodes. How to count how many nodes are existed. Very simple process, sir. Counting the nodes is nothing but here just I will call a utility function like a t dot. So since the return type we are expecting, I am calling print off. Okay, so print off. So I am taking t dot. So count nodes function I will pass. Okay, so here I am going to send a t dot root node. We have to identify how many nodes are there. I think here we have 15 nodes are there, right? Let me check. So def, I am writing code for count nodes. It is having self and then node. So if node is equal to none, that means if there is no nodes, so simply how many nodes are there, sir? 0, right? Otherwise, I am implementing a recursive process. Left count is nothing but self dot count nodes. Can you please count in the left subtree of this node? And can you please count how many nodes are there in the right subtree? Then at last we have to return. At last we have to return left count plus right count plus 1. Simple function, sir. Nothing is there here. Consider I have 1 is there, so 2 is there, so 3 is there. And here we have 4 and 5. Okay. And assume for this left child is not there, right child is 6. What is the output that we are expecting? 1, 2, 3, 4, 5, 6 nodes are there. How this function is going to work? First we will send the root node, which is nothing but 1. Is that node is equal to none? No. Then we are calling left subtree. I mean left subtree count of the nodes. That is nothing but 2. And right subtree count of the nodes, which is nothing but 3. We are calling recursively. First left of subtree will come. Again it will call for 4. Then what will happen? For 4, again it will call for left subtree. So it is going to return none. Then it will return 0. So its left count is nothing but 0. Right count nodes is nothing but 0. This node count is what? 1. 0 plus 0. 0 plus 1. That will be returned here. So here also left subtree is 0, right nodes are not there 0, 0 plus 0, current node count is 1. These 3 values 0 plus 0 plus 1. Now here what will happen? Sir, for 2 how the data is going to come? Its left subtree count is nothing but 1, right subtree count is 1, 1 plus 1 2 and 1. So into this we are going to get 3 nodes. Similar to this, for 6 left node is 0, for 6 right node is 0, 0 plus 0 count is 0, plus this node count is 1, it is going to return 1. This will become 0, right? It will return 0 and it will return 1. 0 plus 1, 1 plus 1, this will become 2. 3 plus 2, left count, right count. 3 plus 2 will become 5. 5 plus current node count, 6. So who is going to call this? For them, it is going to return 6. So recursively, we are calling. How we implemented that in order, pre-order, post-order? In the same way, we implemented like this. Can you please confirm, is the concept is clear up to this, whatever I covered, friends?
Yes, sir, clear.
Right? No doubts, right?
No, sir.
Right. So let me execute really whether we are getting this output or not. Sir, 15 nodes are there. If you want same algorithm, we can write even for sum of nodes. How you can identify some of the nodes? Node self comma node I am taking. If your node is equal to none, then its sum will become 0, right? Otherwise, what we are going to do? Left sum we are going to count. Same recursive function I am taking, where I will pass a node dot left, and right subtree sum I am taking self dot. So sum of nodes I am calling by passing node dot right. At last, what we have to do? We have to return left subtree plus right subtree sum plus a current node data. Don't take one because we are not counting. We are calculating sum. If you want, I will draw this diagram also. Please listen carefully. Consider I have 1 is there, so 2 is there, so 3 is there, and here we have 7 is there. Okay, and here we have 4 is there. Just for example. Now observe carefully. First, we are going to call this root node. It will come here. It will come here like that. In the bottom, sir, its left subtree is nothing but 0. It will return 0. Its right subtree is 0. It will return 0. 0 plus 0, 0, current node data 7. So the sum will become 7. This left subtree is 0, right subtree is 0, 0 plus 0, 0 plus 4 is nothing but 4. For this, we are going to return 7, and for this, we will get 4. Right. Sir, 7 plus 4, which is nothing but 11. 11 plus 2, because left sum, right subtree sum, current node data. 7 plus 4, 11. 11 plus 2, 13 it is going to return. So here left count is left subtree sum is 0, right subtree sum is 0, 0 plus 0, 0 plus 3 will become 3. So 13 plus 3, which is nothing but 16, 16 plus 1, it is going to return 17. Like this, the total sum what we are getting is nothing but 17. But I don't know how many nodes are there here, but let me check. If you call sum of nodes, all these elements will be added. Okay. So let us cross check what will be our output that we are going to get for this. Sir, it is nothing but 120. If you check, we are going to get 120 because a big tree we have provided, right? Based on that, I performed calculation. Can you please confirm how to calculate this sum of nodes? Is it clear?
Yes, sir, clear.
Is the count nodes, sum of the nodes, is it clear, friends?
Yes, sir.
Right. Now, next one, I want to find out height of the tree. I want to find out height of the tree. So same recursive method only, I'm going to call, so height of tree. I will pass the node. If you take the same example, what is the height? 1, 1, 2, right? 2 or 1, 2, 3 is the right. 3 is nothing but the count what we are going to get. Let me cross check whether we are getting the same output or not. Right. Sir, how to implement the code for that? I'm going to take def height of tree I'm taking, where I will pass a self comma node. Sir, now if the node value is equal to none, if node value is equal to none, then I'm going to return 0. Otherwise, I'm taking left subtree height. How to calculate? Self dot height of tree I'm taking, where I'm going to pass node dot left. Similarly, right subtree height is nothing but self dot I'm taking, so height of a tree, where I'm going to pass a node dot right. I will return how we can able to calculate height, sir. Maximum of left subtree height, right subtree height, okay, and then plus 1, because the current node height will become 1. Let us see how it is going to work. This node, this tree height we are calculating. So here, if you take the node 7, what is the height of left subtree? When there is no node, its height will become 0. So it is going to return 0. It is going to return 0. We are finding maximum among these two. What is the maximum among these two? 0 only. Plus current node height is nothing but 1. So 0 plus 1, it will return 1. What about here? So 0, 0, and this node height is 1. 1 comma 1. Maximum is 1. Current node height is 1. So it will return 2. So here left subtree count is nothing but 0. Right subtree count is nothing but 0. Then this third node height will become 1. So maximum among these 2 and 1 is nothing but 2. And the current node height is 1. It is going to return 2 plus 1, which is nothing but 3 is nothing but the height. But if you take this tree, I think 1, 2, 3, okay, 4, 5, 6, 7. So 8, 9. So like this, we are going to get 8, 9, 10, 11. So 12, 13, 14, 15. So this is height 1, 2, 3, 4. 4 is nothing but your height. For this tree, we have to get output as 4. Let me cross check whether we are getting 4 or not. Just I'm running the code and you can see last line 4 is nothing but height. How to calculate this height of the tree? Is it clear for you people?
Yes, sir, it is clear. Sir, can I ask one doubt?
Yes.
Sir, how we can build this type of logic, like recursive logic? We are
Sir,
not
it
able
is-
to understand like how we can develop the logic when we are
Sir,
seeing this.
here nothing is there, sir. Actually, tree data structure and graph data structure I'm going to take only in the special classes. Even the students are going to tell, sir, you need to complete that in the regular classes only. Means I won't accept. The reason for that is, you can see if you miss this logic, continuity, if you see, I covered almost 4 programs. 4 programs are same logic only, right?
Yes.
The simple hidden secret is nothing but, suppose if you have a tree like X, its left subtree is Y, its right subtree is Z. The same structure will be there for here.
Yes.
Same structure will be there for here. If they are asking maximum element between a maximum element in the tree, first you are going to consider how to find out maximum element for this tree. How to find out maximum element for this tree? Try to take left maximum and try to take right maximum, and you have to compare with root node. So what is the maximum among these three? Is our result or not?
Yes.
Suppose if it is attached to the some other node, okay, some other tree will be there like this, then what we have to do? Whatever concept that you applied, you have to repeat for left and then right and for current data. If you apply these 3 logics, automatically it will be calculated for any big tree. See here, how many lines of code we have taken? Almost 4 lines. It is the same even if you have 100 levels also. That is the power of recursion. Got it?
Yes, sir.
Yeah, it is a very simple data structure if you observe at the in depth. But some people are going to feel, if I'm getting any question on the tree data structure, so maximum people are going to feel it is very difficult. But nothing is there. You have to think and you need to apply the recursion logic. So there itself the problem is going to be reduced. Got it?
Yes, sir.
Everyone please confirm how to calculate this height of the tree. Is it clear so that I can go for next level? Right. So the next operation is I want to search for an element. Let us see how to search for an element. T dot, I'm going to call search function. For the search, I will pass complete tree, that is a root node. I am searching for 11 and I am searching for 22 and I am searching for 15 and I am searching for 25. The output what I am expecting, 11 is there or not? Yes, true. 22, it is not there. 15, it is there. 25, it is not there. Like that we have to see. Sir, I will construct the logic because some students are getting confusion. So for easiness, listen carefully. I have self is there. I have a node is there and I am going to provide a key. What is my task? So is that a key is available or not? We are going to check. Sir, how to check? We have only one condition. What is that condition? If node dot data is equal to key, then we got the result. I am telling, so result is nothing but true. Result is nothing but true. Otherwise, I am going to return false. Please listen carefully. Suppose consider I have a node like 1 and then 2 is there and I have 3 is there. I am going to give the input as a 4. It is a comparing. We are passing this node, right? We are comparing with this node. Is this node is matched with this node? If it is matched, we are going to return true. But it is not matched. Okay. Consider here I am taking 3. Sir, the data is not matched. But we have to check is the left tree is there or right tree is there. So how you can able to do that cross checking, sir? We have to apply the same process only, right? I'm going to take, I will invoke this search function like it is a class, right? So self dot search of, can you please cross check in the left subtree of this node, is this key is available? If it is true, can you please return true? Now see what will happen. I'm passing, this one is not satisfied. I'm checking the same function I'm invoking by passing the node as left. Now this will become a new tree. Only one node is there. Left subtree is none, right subtree is none. Then we have given the key. What is the key that I have given? 3. Is it the same? No. Then it is not there in the left subtree. We have to check the same process in the right subtree. So if self dot I am taking search, is it there in the right subtree with the given key value? If it is available, return. Sir, here also it is not there. So then what we have to do until getting the last node, we have to, this is the recursion process. We have to check the base condition, right? How you can check base condition, sir? Very simple. If node is equal to none, if there is no node, then simply we can return false or not. Yes. Now observe what will happen. Consider I am giving the input as a 5. First it will check, is 5 root node is none? No. Then we are going to check, is node dot data is equal to key? No, it is not a key. Then can you please check in the left subtree, is that a key is there? No, it is not there. Then check in the right subtree. Okay, it is not there. Again in the left subtree, in left side it is checking. It is not there. It will return false. That means this condition is going to be false. So here we are calling search function. First we called here, then we are calling here. So then it will call for left and then right. Both are not matched. At last it is going to return false. Very simple algorithm, sir. Let me cross check really whether we are getting this output or not. Now you can see, sir, here somewhere node capital N I have taken, it is a small node. Now you can see, sir, true, false, like this we are going to get. Can you please confirm how I implemented this search algorithm? Is it clear?
Yes, sir, clear.
Sir, what about remaining students? Please confirm. Is it clear?
Yes, sir. Clear.
Sir,
Yes.
here how it increments here self 105, sir, 105, 9. Self
See,
dot
we
sets
are
no.
checking is the node is equal to none. So if
Yes.
node is not none, we have to check whether that data is equal to the given key. If it is equal, it will return true. Okay. So
Yep.
consider I have a tree is there like 1 and then 2 and then 3. The node which I have given and 3, here we have 4 and then 5 is there, and we have 6 and 7 is there. Assume I have given the data is 7. Please listen carefully. First it is going to search with root node. Is the data is matched? No. Then
No.
we are calling search of, we are passing its left subtree, which is nothing but 2. And we are passing this key. Is this key is satisfied? No. Again it will call from here, it will come here. Now your node will become 2, key will become 7. Is node is equal to none? No. Is node dot data is equal to key? No. Then what will happen? Again it will be called one more time for its left subtree. So here the node is equal to none, right? That means here it is going to return false. So here also it is going to return false. So here it will return false. Okay. And for right subtree, what we are going to do? We are calling one more time. We are passing this right subtree. So if you pass right subtree, again it will be invoked from the beginning. It will check in the left subtree and it will check in the right subtree. In the left subtree, it is going to return false. In the right subtree, it is going to return here false. Here it will return true. True means return type, right? Automatically it will stop here. If it is the given data is 17, it will return false. It will return false. It will return false. At last we will get false. Got it?
Yes, sir.
Can anyone tell me what is the time complexity of this algorithm, sir? If you tell correctly, then
Big O of N. Big O
Uh-huh.
of N. Big O of N. Big O
big
of
O
1,
of
sir.
n.
1, sir.
No.
It is n.
N. Big O of n. Sir, why n? We have to do this
Right.
process for every node. That's why
Okay.
this is not a efficient one.
BST is efficient.
Yes, binary search tree is efficient. So actually these concepts I should not cover here. But for easiness, if I cover all these things here, then we can concentrate only on binary search tree properties. So remaining things, tree means the same concept only, right? Only the element alignments are going to be changed. That's why I'm going to cover the maximum concepts here. Right. Now, sir, what is my next requirement is, I want to find out maximum and minimum element. Sir, how to find out maximum and minimum element? Very simple. DEF, find max element I'm taking, where I will pass a self comma node. Now please listen, I'm going to check from the beginning. I'm going to explain from the beginning. Consider the tree is, so 1 is there, 2 is there, so 3 is there, 4 is there, okay, so 5 is there. Here I'm taking, okay, 5 is there, or 15 is there, and then 7 is there, 8 is there. Consider like this we have. Please listen carefully. First we have to find out the maximum element. I'm passing the root node as the beginning. I passed the root node, that is nothing but 1. I'm going to check is the node is equal to none. If node is none, how to return the maximum element? -1 is the maximum element. Otherwise, maximum element will become node dot data. Sir, your maximum element will become now what? 1, right? 1 is the maximum. Now, is there any maximum in the left subtree? I'm going to find out. How to find out left subtree is nothing but node dot or self dot. I will find max element of. So how to pass node dot left I'm passing. So now what will happen? What is its left node, sir? 2. It will be passed. Sir, is node is equal to none? No. Then max will become what? Node dot data. What is the node dot data that we are going to get? So 2. Here it is going to return 2. Now your max will become 2 for the second method call. Okay, sir, after this what we have to do? We need to pass this one. We need to pass this one. Where we are going to get max is equal to 4. We have right subtree is also there, right? How to calculate it? So self dot find max element. We are going to pass for node dot right subtree. Sir, here we have, okay, here if you take this one, max is equal to 4. Its left subtree maximum is a none. None means -1. Right subtree max, in the another color I will represent. So its left subtree is none, its right subtree is none. It will return -1 as a max. Now I will remove this one also, better to explain from the ground level. Now we have maximum value is 4, and here left subtree maximum is -1, right subtree maximum is -1. That maximum value we have to find out among these 3. How to find that? If the left value is greater than maximum, your left will become maximum. If right value is greater than maximum, your right will become maximum. Your maximum will become right. Your maximum will become left. At last we have to return maximum. Now see, sir, is maximum left is greater than maximum? No. Right is greater than maximum? No. Return the maximum, which is nothing but 4. Here its left maximum is -1, right maximum is -1. Your as of now maximum is 5, left is -1, right is -1. So immediately it is going to return 15. So here in this example, max will become 2. Left maximum is 4, right maximum is 15. Which is the maximum among these? 15. Like that, here we will get a 7, here we will get 8. So among these 7, 8, 3, we are going to get 8. Among these 15, 8, 1, 15 will be the maximum element. If you want, you can call this by passing max element. Okay, so max element. Find max element. So what output we are going to pass if you root node, if you are passing, it will become 15 because we have 15 as the maximum element. Suppose consider I am not passing this 15, I am passing 5. Then 14 is the maximum. Suppose consider I am giving 15, but -15 I am giving. So maximum is 14. Sir, can I find minimum element? So in the minimum element, I am expecting minus 15 as the result. How to do that? Is it the same process or not? Yes. Whatever algorithm that we have taken, same thing. But in the place of max, we have to take minimum element, except that the remaining things will become same. But how to update that? Have a look once. I'm going to find a minimum element. Sir, initially, so minimum element means we have to return maximum value. In sys module, we have max size function is there, attribute is there, which will return maximum element, something like maximum value in the integers. Okay, but anyway, such type of things won't occur here. And we are finding the node data, and we are going to call minimum for left and right. If L is less than M, left will become minimum. If
Sir,
R
we
is
can,
less,
can we use directly function like max
which
of
function?
max function and min function? here?
I think we can use, no problem.
Yeah, so directly we can use
Max
return
of yeah,
return
yeah,
return
can
max of
return max
MLR
of
MLR
MLR. Yeah, we can do that.
min, but here it is min.
This algorithm is. Now you are going to get minimum element present in the tree. Sir, 15 is the minimum, right? Let me take here, I am taking 15, and somewhere here I will take minus 10. Is it minus 10 is the minimum or not? Yes, like that we are going to get. So even here also you can replace max, return max of M comma L comma R. That's all. This is the way how to find out a minimum and maximum element in the binary tree. Sir, please confirm, is this concept is clear for you people, friends?
Yes, sir.
Yes, sir. Clear.
Yes, sir.
Right. Right. So next one, I need to check equal, but before that, I will implement these two. Number of leaf nodes. How many leaf nodes are there? I need to count. Number of leaf nodes. We are going to pass a node. We have to find out how many leaf nodes are there. How to
Yes,
find
sir.
out, sir? Suppose if your node is equal to none, how many leaf nodes will be there? 0, right? Suppose if node dot left is equal to, okay, none, and node dot right is equal to none, then what is the meaning? Is it a leaf node or not?
Yes,
Yes, sir.
Then we are going to return 1.
one.
So otherwise, what we have to do? You need to call recursively for self dot number of leaf nodes function we are calling for node dot left plus whatever result we are getting. So same self dot. So number of leaf nodes we have to call for node dot right. Okay. For our convenient purpose, just I am removing this word called nodes. And in the function I will call so t dot number of leaf. So what it has to return, sir? How many leaf nodes are there if you take this particular tree? Okay, if you take this particular tree, 1 second. Yeah. So can you please tell me how many? Yeah,
Four.
how many leaf nodes are there here?
4.
Right. So here, how many leaf nodes that we are going to get? We need to get 4 leaf nodes, right?
Yes, sir.
One
Yes,
second.
sir.
One second. One second. Second. Right. So let us see how it is going to work. Here I'm going to call this function by passing. So first we are going to pass a root node, that is a 1. So is the node is equal to none? No. Is left child is equal to none? No. Is right child is equal to none? No. Then call the same thing for left recursively, right recursively. So it will call like this and it will call like this. This function is going to call this one and this one and this one and this one. So coming to the bottom, here for 4, is node is equal to none? No. Is left child is none? Yes. Is right child is none? Yes. Then it will return 1. So this one is going to return 1. 1 plus 1, it is going to return 2. So this will return 1. This will return 1. 1 plus 1 is going to return 2. 2 plus 2. Total 4 leaf nodes are there. Suppose consider here if you don't have this node, it will return 0. 0 plus 1 will become 1. It will return only like that it is going to return. If you want, let me cross check whether we are getting the same output or not. I think if you take that example, it is going to have 8 leaf nodes, right? Because in the third level it is there, we have total 8 leaf nodes are there. Let me remove one element and check how many leaf nodes will be there. Only 7. Sir, is it working perfectly or not? Yes, this is the way how to find out the number of leaf nodes present in the tree, sir. So if they are asking sum of leaf nodes present in the tree, what you have to do? Sir, very simple. Here same function we have to do. Instead of return 1, you have to take that node dot data. Okay, node dot data that you have to call recursively. Okay, this is nothing but what we are going to get. Can you please confirm how you can able to find this number of leaf nodes present in the tree? Is it clear for you people, friends? Please confirm.
Yes, sir, clear.
Sir, I request everyone to please confirm. Clear up to this?
Yes, sir. Sir, here we are returning that number
Hmm.
once go in the code, sir. Where this return one store, sir? The return statement.
It is a stack, right? So whenever we are calling this one, it is going to be written. In this place, we will get 1.
Okay.
Okay.
Yes, sir.
Right. So what is the next function that we are trying to implement here is I want to print all paths. I want to print all paths. That is, for example, if you take so 1, 2, 3, 4, 5, okay, so 6 and then 7. What is the first path that we have? 1, 2, 4. Second path 1, 2, 5. Third path 1, 3, 6. Fourth path 1, 3, 7. Like this, we have to print all paths. It is a bit tricky code, sir. Okay, it is a bit tricky code. Very interesting code. You people are going to get maza on this code. Let us see what I'm going to do. Sir, I'm going to use a stack data structure for this. Previously, when we are printing level wise, we used queue, right? But here I'm going to use a stack. How I'm going to use? Listen carefully. For this, I need 2 methods. One is print all paths. So which is going to create an empty stack, and we are going to call self data print all paths utility function I'm going to pass, where I will pass the current node as well as a stack. So now I'm going to write that utility print all paths underscore util function, where it is taking a node as well as a stack. Now consider the same example. Sir, I created one stack. Okay, I created one stack. Listen carefully. I created one stack. Okay, fine. My stack is ready. Then, sir, I'm going to pass the node, which is the node that I'm going to pass 1. Now what will happen? We are going to check, boss, if is the node is equal to none. If node is equal to none, don't do anything. After that, yes dot append of your node dot data I'm appending. Now check, is 1. Is it none? No. Then push that 1 into the stack. Please listen carefully. Push this 1 into the stack. I pushed 1. After that, what we are going to do? Sir, please check whether it's left child and right child are empty. If node dot left child is empty and node dot right child, okay, right child, is it empty? Then what is the meaning? We came to the ending, right? Last node we got. If you got to the last node, what we have to do? Print that stack. Then try to delete the latest element and return. So anyway, I will explain this code. Is my node that is 1? Is its left child is none? No. Is its right child is none? No. That's why this condition is never satisfied. Once if it is satisfied, I will explain. Then, sir, we are calling the same function like self dot print all paths util function I'm passing. For node dot left child, I will pass this stack. Similarly, same thing I'm calling for right. First, let me check for node dot left I'm passing, sir. So now this will become your node, right? Sir, is this node is equal to none? No. Then append node dot data. Sir, 2 got appended into the stack. Now what I'm going to do? Again, we are calling for node dot left 4. Sir, is 4 is equal to none? No. Append the data. 4 I appended. Now, is node dot left child is none? Yes. Is node dot right child? Is it none? Yes. Then can you please print the stack? What is the stack, sir? 1 to 4. It will print. After that, what I'm doing? Yes dot pop. Do you know the latest element that is 4 got removed? Now in my stack, how many elements are there? Only 1 and 2. Okay. So now it will return the control. And sir, node dot left completed, right? Node dot left completed. But for the right part is pending, right? It will call for node dot right. Sir, is node is equal to none? No. Please append the data, which is nothing but 5. Completed. So now, can you please check, is this node left child is none? Yes. Is it right child is none? Yes. Can you please print that stack, sir? 1 to 5 that got printed. Now please listen carefully. Its left child is completed. Its right child is completed. And the main node left child completed. Now we are going for main node right child. If you want to go to right child, these 2 methods has to be completed, right? So then only it will go. But when we are doing this, I am writing one backward step. What is that backward step is? Again, I am going to pop. Okay, so here, because of this pop, this item is also going to be removed, and because of this pop, 1 is removed. So left part visiting got completed. Now what will happen? We came to the right part. We came to the 3. Is 3 is none? No. Can you please append the data? 3 got appended. So is left child is none? No. Is it right child is none? No. Then can you please call for 6? It's left child we passed. That is nothing but 6. Now what will happen? Please listen. We are executing this one. So it's left child. That is nothing but 6. Append the 6 data. Yes, appended. Is left child is none? Right child is none? Yes. Then print that 136 and pop the item. That is last item 6. Then so left child got completed. We have to execute for right child or not? Yes. Okay. Then what will happen? We are going to execute for right child. So when we are executing for right child, so node data data we have to append. 7 is appended. Then, so now what we are going to do? So we are going to check, is its left child is empty? Yes. Right child is empty? Yes. Print that stack. After printing, we have to pop 7. Now these 2 method calls got completed. Yes dot pop. It will remove 3 also. So I think there is no path, right? All the method calls is going to be terminated. Okay, this is the way how we are going to get the path. If you want, let me call this function and check t dot. So print all paths, and I'm going to pass a t dot root. For this, let us see how many paths we are going to get. Print paths is taking one argument. We have given 2. What is that? We have to pass the. No. 1 second. We have to pass this one. Correct only, right? T dot root only it is expecting. No, it is not at all expecting anything. So we are not required to pass anything. It will print all the paths automatically. Now you can see here. Name node is not defined. Did you mean none? Something. Print all paths util.
So while calling print all path, we need to pass node as well. At 136 line, we need to add self comma node. And then while calling the function, we need to pass t dot root.
I will do one thing. Here while calling,
At 136 line, we can add node.
better I will take self dot root. Now is it correct?
Yes.
First time we are calling with the root by passing the root. Okay.
Yes.
Now it is going to work. I think so. Let me cross check. Yeah. Have you observed? Sir, is it our tree or not? Yes. If you see, what are the nodes that we have? 1, 2, 3. So next here 4, 5. Okay. Here 6, 7, and here 8, 9. So 10, 11, and here we have given 12, 13, and 14, 15. Maybe some nodes got altered. So you can see 1, 4, 8 we got, and then 1, 4, 9 we got. And then this value also we got. Like this, every value it is printed. Everyone please confirm, is this concept is clear for you people, friends?
Yes, sir.
Sir, here we are using backtracking as well.
Yes, backtracking as well as, because once if you are visiting of that node got completed, printing in the path, once if that left child and right childs are visited, we have to remove that. So that removal, compulsory backtracking only, right?
Yes. Okay, sir.
Sir, you are using mouse for drawing this mouse, sir. You are using.
No. Oh yeah, I'm using mouse only. Right. Because I don't have any work. I will be on only in these Zooms only, right? That's why it is practiced.
Nice, sir.
Right. So printing all paths got completed. Now we have to check whether 2 trees are equal or not. Suppose if I have 2 trees are there, we have to check whether those 2 trees are equal or not. How you can able to check? So I'm defining equal method where I'm going to pass 2 nodes, node 1 and then node 2. Suppose if node 1 is equal to none and node 2 is also none, then what is the meaning? Both are empty nodes. That means both are equal. Suppose if node 1 is equal to none, or if node 2 is equal to none, that means if any one node is there, other node is not there, then immediately both are different because one tree is not having the same number of elements like this. Then we are going to return self dot. I'm checking equality equal of. Can you please check node 1 dot left, comma node 2 dot left? And can you please check self dot equal of it's node 1 dot right child, okay, and node 2 dot right child. And even so node 1 data must be equal with node 2 dot data. I will explain with a simple example so that you can get clarity. Consider the first tree I have 1, 2, and then 3. Another tree, so 1, 2, 3 is there. Now please listen carefully. This is the first pointer. This is the first pointer. Is node 1 is equal to none? No. Is node 2 is equal to none? No. Then is node 1 is equal to none or node 2 is equal to none? No. Then we are calling equals method by passing node 1 left and node 2 left. These two we are passing. So it is up to this function call. It will execute again. Sir, is node 1 is equal to none? No. Is node 2 is equal to none? No. Then we are passing its left subtree. It's left subtree. Here both are none, right? Then it will return true. Here 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 it will return true. Now for this we got a true. For this we got a true. And we are checking this data. Node 1 dot data is equal to node 2. If these 3 are true, then it will return true. Like this we are going to check. If anywhere mismatch occurred, then immediately it is not valid. Sir, for converting this, just I will take only 3 nodes. Better I will take this one in the comments. So T1, tree 1 is equal to, otherwise, one, two, three, level list 1, tree 1. So create a tree by passing, and I'm printing T1. So same thing we have to do it for T2 also. List 2 I'm taking. So T2, T2, T2. So now let us print up to this, sir. Yes. Now I'm calling. Can you please print? So T1 dot equal of. We are going to pass a T1 root node, T2 dot root node. If I'm passing these two, whether 2 trees are equal or not. Yes. Let us change in the second tree. I'm taking instead of 3, 13. Is these 2 trees are same? Is these two trees are same? Yes, we are getting same. One second. Here I have taken L1 only. We have to create by using L2. You can see my first tree level is nothing but 1, 2, 3. Second tree is nothing but 1, 2, and then 13. And then false we are getting. I think, friends, you people got very clear clarity how we can check for equality. Can you please confirm, friends, is this concept is clear for you people, guys?
Yes, sir. Clear.
Sir, clear, sir.
Right. So last one, copy list. Sorry, copy tree. How you can able to make a duplicate copy. Okay, let us see how we can able to make a duplicate copy. Sir, how to make a duplicate copy? Very simple. DEF. So copy tree I'm taking. Okay, copy tree I'm going to take, which is going to take a self comma, and I'm taking node. So if your node is not equal to none, we have to create exactly another tree. Temp is equal to self dot node I'm creating by passing current node data, and temp dot left will become, again we are going to call self dot copy tree method by passing its left subtree, and I'm going to create a copy of right tree by taking temp dot right. And at last what we have to do, we need to return that temp. If node is equal to none, then we are going to return none. So just for example sake, I'm taking, listen carefully. Consider I have a node 1 and then 2 and then 3. If there is no node, it will become none. I want to create a copy of this. First we are going to pass 1. Is it none? No. Then create another temp with the data node dot data. Yes. Then node dot left will become, again we are passing node dot left. So here is node is none? No. It will create a node with 2, and left child will be the right child. For left child, it's left child I am passing. Is node is not equal to none? Yes. No, node is equal to none. Then it will return none. Here also none. So now another copy will be created. Like this we are going to get, sir. Let us execute and cross check. Sir, same thing I'm taking. L1 is this one, T1 is this one, L2 I'm not creating. Okay, T2 I'm not creating. But what I'm doing is, I want to perform copy operation. How to do that? T2 dot root is equal to, sir, can I take T1 dot copy tree by passing T1 dot root node? Then try to print and check for equality. Now see what will happen. T2 is not defined. Do you mean T1? So first we have to create T2, which is nothing but root, which is nothing but a tree. Then we have to check. Sir, is the copy is maintained or not? Yes, you can see that the copy got maintained. This is the way how we can able to perform copy operation. Everyone please confirm, is the concept of this one, is it clear for you people, guys?
Yes, sir. Clear.
I request everyone to please confirm. Is it clear, friends? Right. With this, tree data structure module got completed. Okay, tree data structure module with a clear explanation. I have given everything, sir. Okay. So with this, I'm going to stop today's session. Please don't leave the meeting.